Hello everyone and welcome to this video on the Python programming language. So in this video I will show you how to create a Monte Carlo simulation to simulate and forecast the future cumulative returns of the S&P 500. Please note that a Monte Carlo simulation has some challenges. For example, the simulation relies heavily on historical data to predict future returns, and this can be problematic because past performance is not always indicative of future results. Now, I'm currently on Google's website called colab.research.google.com because it makes it easy to get started writing Python code. So if you're going to code along with me, just go to this website and then log in using your Google account and get started writing your code. So to start writing your code with me, go ahead and click on File, click on New Notebook in Drive, and a new tab will open up for you, and then eventually a new cell will open up for you. And before we begin, if you like the videos on this channel, then be sure to click that subscribe and like button, and to be notified about videos from this channel, hit that bell notification. Alright, so the first thing that I'm going to do here is I'm going to import the libraries that I plan on using for this program. So I'm going to import NumPy as NP. I'm going to import pandas as PD, and I'm going to import matplotlib.pyplot as PLT. And Google Colab gives me some suggestions here. So I'm just going to tab over, and I'm going to get rid of what I don't want, which will be that Seaborn library. So I'm just going to delete it. Okay, and I'm just going to run this cell by clicking this button here to the left, and this will let me know if I made any mistakes. Okay, also I should say that you can get the code in this video or the data set or just support the channel on Patreon at patreon.com/computerscience, and I will leave a link for that in the description below. And the material in this video is purely educational and should not be taken as professional investment advice. Okay, so with all that being said, let's create a new cell by clicking that code button in the top left. And now I want to get the data set, and this data set is going to contain information on the S&P 500 from the VOO ETF. And the idea here again is to simulate the future cumulative returns of the S&P 500, and VOO contains information on the S&P 500. All right, so we're going to get the data set. So I'm going to create a variable called df, which will be short for data frame, and I'm going to set it equal to pd.read_csv, and then left parentheses and right parentheses. All right, so I need to load the data set. So I'm going to go over here to this folder looking icon that says files. I'm going to click on it, and I'm going to click on this upload icon. Okay, and I'm going to upload voo.csv. All right, I get a little warning. I'm going to click OK because the warning is okay, and I'm going to exit out of the left pane. Okay, so now I have my file uploaded. Let's click on it one more time. It's voo.csv. Let me exit out of it. So I'm going to put in here single quotes voo.csv, and then I want to show the data. So I'm just going to type df here. All right, so let's go ahead and run this cell and take a look at our data set. So we have the columns date, open, high, low, close, ADJ close, and volume. And we can see that we have rows from January 2nd, 2019 all the way to December 30th, 2022. Okay, so that's 1008 rows of data and 7 columns. Okay, so I want to make the date column the index. So I'm going to put comma here. I'm going to put parse underscore dates. I'm going to set it equal to true. And then index underscore call, I'm going to set that equal to our date column. And let's run this cell again. And now the date is our indice. Okay, so let's create a new cell. And now in this cell, I'm going to simulate future paths. Okay, so let me talk a little bit about a Monte Carlo simulation. So a Monte Carlo simulation is a technique used to perform sensitivity analysis. It predicts a set of outcomes based on an estimated range of values versus a set of fixed input values. The method uses a random sampling of information to solve a statistical problem. It is used to measure risk and understand the impact of risk and uncertainty in various forecasting models. So Monte Carlo simulations show the probabilities of various outcomes, including the impact of processes in use. Okay. All right. So let's go ahead and continue for now. The first thing I'm going to do is I'm going to create our simulation parameters, right? So how many simulations do we want and how far do we want to forecast out? So here I'm going to put num underscore simulations, and I'm going to set this equal to 10 for now, and then I'm going to put forecast days, forecast underscore days. I'm going to set this equal to 365. Maybe I should have put 252 instead for 252 trading days approximately in the year, but 365 is fine. At least I believe it's 252. I will have to check that. Okay, now when we say Monte Carlo simulation, we're talking about a computer-based method that uses randomness, just like casino games, to predict various outcomes. And the purpose of a Monte Carlo simulation is to predict the probability of a variety of outcomes when the potential of random variables is present. All right, and so that's what we're going to kind of simulate here. Okay, so next I want to initialize the simulation array with all zeros, and specifically a two-dimensional array. A two-dimensional array. So here Google gives me a suggestion. It says simulation underscore array is equal to np dot zeros, and then inputs num simulations and forecast days, and that looks good. So I'm just going to tab it over, but I'm going to change the name to be just simulations with an S. All right. Okay, so next I'm going to get the last adjusted close price, and also I'm going to change this I here to be a capital I. All right, so let's get the last adjusted close price, and Google gave me this nice suggestion. Let's just tab over last underscore price, set it equal to df adjusted close price at position -1, which will be the last one. I'm going to put dot I lock here. Okay, and so this will get the last adjusted close price for us. All right, next I'm going to calculate the daily returns, and I'm going to drop and remove any NA values. So I'm going to create a variable called daily underscore returns. I'm going to set it equal to df adjusted close dot percentage change. So just like what Google has suggested here, I'm going to use this. I'm going to tab it over, and then I'm going to put dot drop in a left parentheses and right parentheses. Okay, so we're getting the cumulative daily returns, and then we are dropping any NA values. All right, so I think that looks good. Let's run this cell. Let's create a new cell, and here I want to loop through the number of simulations to forecast future cumulative returns for this asset. And what's this asset? This asset is VOO, which contains information on the S&P 500, right? VOO is just an ETF. Okay, so for I in range, num underscore simulations, I want to get the cumulative return. So here I'm going to put, I want to get random daily returns of size forecast days and return its cumulative return. Okay, and note that the daily returns can choose the same return multiple times, or random daily returns can choose the same return multiple times. Okay, so let's see what Google suggests here. It suggests simulations at position I. Okay, I don't want that. All right, so I'm going to create a variable called cumulative underscore returns. I'm going to set it equal to np.random, and actually let me go ahead and just put a comment here of what exactly we're going to do. So we're going to return an array of size forecast underscore days that contains randomly selected daily returns and calculate that cumulative return. Okay, so that's what we're going to do. So let's bring this on back over. Okay, so np.random. So we're going to randomly choose a daily return. So random.choice daily underscore returns. We're going to set the size equal to forecast days. So I'm just going to tap over and tap over. And then we want to set replace equal to true. And we want the cumulative return. So I'm going to put dot cum sum, left parentheses, right parentheses. Okay. So now that looks good. Next, I want to get the number of simulations with the random cumulative returns. No, maybe that's not correct here. How about here? I want to get the simulations with the random cumulative returns. Okay, I think that's more like it. So Google gives me this nice suggestion here. It looks pretty good, but I'm going to change it up a little bit. So I'm just going to tap over. So we're going to get our simulations, right? Right now, simulations is a two-dimensional array. So we're going to get each simulation. So we're going to get the first simulation is in position I. We want everything. I'm going to set it equal to last price times 1 plus cumulative returns, and that should do it. Okay, and let's print simulations to see what it looks like. Okay, so we're going to get, hopefully we'll be printing 10 simulations, each having 365 random cumulative returns. All right, so let's go ahead and run this. Okay, and it looks pretty good. This is our two-dimensional array that contains our 10 simulations, right? And each simulation contains 365 days worth of random cumulative returns. All right, so let's create a new cell, and just to kind of help you understand exactly what we just did here, I will give an example. So for simulation 3, I'm going to show the first 4 random cumulative returns out of the 365 random cumulative returns, starting from index 0 up to but not including 4. All right, and Google gives me this nice suggestion, and I'm just going to tab over, and what we can see is that Google put 2 here. So 2 would be our third simulation, right? 0 would be the first simulation, 1 would be the second, and 2 would be the third. And we only want to show 4 random cumulative returns. So that's going to be 0, 1, 2, and 3. So we never get to reach 4 here. All right, so let's go ahead and run this. And now we can see one of our simulations, right? It's actually the third one. And we can see our random cumulative returns, at least 4 of them, 4 out of the 365 that were created. All right, so let's create a new cell, and now we're going to plot the results. So here I'm going to just type plot the results. Let's see what Google suggests here, if anything. All right, so it didn't suggest anything. So I'm going to type plt.figure, and I'm going to give my figure a fixed size, and I'm going to set it equal to 10 by 6. And then I'm going to type plt.plot, and we're going to plot the simulations, but we're going to plot it transposed. So I'm going to put .t here, and I want to give it a color. So I'm going to set the color to be purple, and I'm going to give it an alpha. So I'm going to set alpha to be equal to 0.25. And let's give this plot a title. So I'm going to type plt.title, and it will be Monte Carlo Simulation of Future Prices. All right, and then I'm going to type plt.x label and make it days. I'm going to type plt.y label, make it price, and then type plt.show. And Google has already made all these suggestions for me, so I'm just going to tap over, and let's run this and take a look at our simulation. All right, so there we go. We have our 10 simulations here, and of course we're going to want more to make it a little bit more accurate, right? Give it more sample sizes. All right, so I like this, but I'm going to make it a little bit more colorful. So let's create a new cell, and now in this cell I'm going to basically take everything that we just did. So I'm going to highlight all of it. I'm going to copy using Control C, come down below here and paste it using Control V, and change just a few things. So I'm going to get rid of this plt.plot. Well, I guess I can kind of keep some of it. So I'm just going to Control exit. I'm going to cut it, and instead of putting that plot there, we're going to loop through every single simulation and then graph it and let the program decide what color to give each simulation. So for I in range num simulations, I'm just going to tab over, and we're going to type plt.plot, and we're going to plot simulations. We're not going to give it a color, so we're going to get rid of that. Alpha can be 0.25. I think that's fine. Let's put a right parentheses here, and just to make it a little bit simpler, let's put a square bracket here. All right, so we're just going to plot simulation at position I. So let's run this, and now we can see it's a lot colorful, a lot more colorful than the previous one, right? But still the same simulations, okay? Just not all one color of purple. Okay, so I said that we probably want to run more simulations to get more samples. So let's change the number of simulations to 1000 instead of 10. So I'm going to run this cell. Now that that has been changed, I'm going to come down here. I'm going to run this plot here. That looks terrible. Let's see what's going on. I need to run this, and I need to run this loop here. Okay, and now let's go ahead and just run that as well. Now let's run this plot, and let's see what we get back. Okay, so now we can see 1000 simulations, and let's come down here and let's run this plot, and we get 1000 simulations as well. So it's pretty cool. Well, thanks for watching the video, and a special thanks to the Patreon supporters on patreon.com. Again, if you would like to become a supporter of this channel or get the code or data sets, I will leave a link to the Patreon page, which is patreon.com/computerscience, in the description below. Thanks for watching, and I hope you all have a great day, and I will see you all in the next video. Bye for now.